Alright, so today we're going to be simplifying square roots. So what we have first here is we have our product property of square roots. So if I'm taking the square root of a times b, I can break that up into two separate square root signs. So I can do the square root of a times the square root of b. Just like in here in this example, I've got the square root of 63. I can rewrite 63 as 9 times 7. So the square root of 9 times 7, and then I can break each one of those into a separate square root sign. So the square root of 9 times the square root of 7, and then since the square root of 9 is a perfect square, I can change that into a 3, and then leave the square root of 7 as the square root of 7. And that's going to be simplest form for this example. So simplest form, the number under the radical side can't be divided by a perfect square. And again, perfect squares were numbers that when I take the square root of it, I get a whole number. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. And so the second rule for simplest form is that I can have no radical sign in the denominator. So to simplify this, to put it in simplest form, I'm going to find the largest perfect square that divides the number evenly, and then write it as a product of the two square roots. So with I'm going to do this first example here with square root of 216. I can go through my list of perfect squares. So like 216 divided by 4, which is a perfect square, gives me 54, but I can find a larger one. I think the largest ends up being 36. Yeah, so 216 divided by 36, which is my perfect square, gives me 6. So I can rewrite this as the square root of 36 times the square root of 6. Then obviously 36 is a perfect square, so when I take the square root of it, I get 6 times the square root of 6, and that'll be my final answer. That's simplest form because the number underneath the radical sign, which is 6, can't be divided by any other perfect square evenly. The example down here on the bottom, 54x squared. I can separate that right away into the square root of 54 times the square root of x squared. So then, biggest perfect square that divides 54 is 9. So square root of 9 times the square root of 6. That's how I'll break that down. And then times the square root of x squared. Square root of 9 is 3, the square root of x squared is x, and then the square root of 6 is 6. Again, the order doesn't matter. I can move them around however I want, and it looks nice and neat because 3 times x times radical 6 looks a lot better than 3 times radical 6 times x. Here we have so quotient property of square roots, which is saying the same thing as what we just went over, except now with division. If I have two things underneath a radical sign that are being divided by each other, I can divide the top and divide the bottom. Over here, I've got square root of 11 divided by 4, and so I can do the square root of 11 divided by the square root of 4. And just to make sure, I don't want to have a radical sign in the denominator, so the square root of 4 is 2. So that would be my final answer. Let's do this one right here. So I've got the square root of 32 divided by the square root of x squared. The largest perfect square that divides 32 is 16. So I can change that into the square root of 16 times the square root of 2 divided by the square root of x squared. And so the square root of 16 is 4 times the square root of 2, and the square root of x squared is x. And so that would be my final answer. Again, everything under the radical side can't be divided by a perfect square, and then have no radical sign on the bottom. Last one will be this one over here on the bottom right. So I'm going to do the work over here. Square root of 245 times the square root of b squared divided by the square root of 125. I think 245. The largest perfect square that divides 245 is 49, so I can rewrite that as the square root of 49 times the square root of 5. again, because 25 or 245 divided by 49 equals 5, I can rewrite it as multiplication of the two. Then times the square root of b squared, all divided by 125, the largest perfect square is 25, times the square root of 5. Again, I can take the square root of each of these. Square root of 49 is 7, square root of b squared is b, then times the square root of 5. On the bottom I'll have the square root of 25 is 5, times the square root of 5. Now, I have a radical sign in my denominator, and what I can do is, right here I've got the square root of 5 on the top and the bottom, and those actually cancel each other out because the square root of 5 divided by the square root of 5 is 1. So my final answer is 7b divided by 5. And that's my final answer. And there's your homework.